Sniper rifles have changed more in the last 150 years than almost any other class of firearm. From simple single-shot rifles with basic optics to today's modular, multi-caliber precision systems that integrate electronics and ballistic computers. Each generation of sniper rifles reflects the tactics, technology, and battlefield demands of its era. This is the complete evolution of sniper rifles, explained step by step. The story begins in the early 19th century with a single innovation: rifling. Before rifling, muskets fired round balls from smoothbore barrels, resulting in unpredictable trajectories. Rifling introduced spiral grooves that stabilized the projectile, dramatically increasing accuracy. The first major marksman rifles included the Sharps rifle, used during the American Civil War, and the British Whitworth rifle, famous for its hexagonal bore and capability to reach out to 801,000 yards, an extraordinary distance for its time. These rifles were usually single-shot and loaded from the muzzle or breech. Optics were primitive. Early telescopic sights were long, fragile tubes with limited magnification and no standardized reticles. Despite their limitations, these rifles created the first true long-range specialists on the battlefield, marksmen who fired deliberately instead of volley shooting. While not yet snipers in the modern sense, these individuals demonstrated that precision could alter battlefield outcomes. This laid the foundation for what would become a distinct military discipline. World War I transformed every aspect of warfare, including long-range shooting. Trench warfare created static battle lines, where soldiers exposed even a small portion of their head or equipment above the trench. It quickly became clear that a dedicated capability was needed to hit these tiny, fleeting targets. All major powers rushed to create sniper units. Germany fielded scoped Gewehr 98 rifles with early 3x and 4x optics. Britain used SMLE sniper variants with offset scopes due to the rifle's action design. Russia employed Mosin Nagant sniper rifles, an early pattern that would evolve significantly in the coming decades. Scopes improved dramatically: better glass, more robust construction, refined elevation and windage adjustments. But the optics were still fragile and limited in low-light conditions. Snipers became highly valued assets. Their role expanded beyond simply hitting enemies at range. They conducted counter-sniper operations, observed enemy movement, and eliminated critical targets such as machine gunner crews and officers. World War I firmly established the sniper as a specialized soldier requiring dedicated training and specialized equipment. This era marks the true beginning of sniper doctrine. World War II saw snipers deployed on every major front. Unlike World War I, snipers were now systematic components of infantry formations rather than improvised units. The Soviet Union made the most significant advancements. The Mosin Nagant M91/30 PU sniper rifle was mass-produced with rugged 3.5 XPU scopes. Snipers like Vasily Zaitsev and Lyudmila Pavlichenko demonstrated the rifle's effectiveness in urban environments. Germany introduced the Kar 98 KZF-41 and ZF-42 sniper variants. These rifles were accurate but suffered from limited field of view due to their small optics. Germany also experimented with semi-automatic sniper rifles like the G43, which offered faster follow-up shots. The United States used the M1903A4 Springfield, a bolt-action rifle fitted with Weaver scopes, and later deployed sniper versions of the M1 Garand, though semi-autos were less common due to concerns about accuracy and scope stability. Japan used sniper variants of the Arisaka Type 97, equipped with offset scopes, while Finland's famed snipers used modified Mosin Nagants with high marksmanship training. By the end of World War II, several core features of sniper rifles were standardized: bolt-action designs for precision dedicated, rugged optics, purpose-built mounts, heavier barrels for consistency. This era proved that precision rifles were indispensable on the battlefield. After World War II, major advancements in metallurgy, ammunition, and optics reshaped sniper rifle development. The Soviet Union created the Dragunov SVD, adopted in 1963. Unlike traditional sniper rifles, the SVD was a semi-automatic designated marksman rifle, designed to extend the effective range of regular infantry. Its 7.62 by 54mm R cartridge and rugged PSO-1 optic made it highly effective. The United States developed sniper versions of the M21, based on the M14 rifle. This semi-auto system performed well in Vietnam, but required meticulous maintenance. Bolt actions were still valued for reliability. NATO nations began refining bolt-action sniper rifles using the Mauser-style actions that had proven reliable for decades. Ammunition consistency also improved, with match-grade loads becoming more common. Scopes saw major improvements: better coatings, more durable internals, mil-dot reticles, introduced in the late Cold War. This era established the difference between sniper rifles, precision weapons for highly trained specialists; DMR rifles, semi-automatic rifles for squad-level accuracy. During the 1970s and 80s, bolt-action sniper rifles became the gold standard for accuracy. The most influential development was the founding of Accuracy International in the United Kingdom. Their Arctic Warfare (AW) rifles pioneered modern features: modular design, folding stocks, adjustable cheek rests, detachable box magazines, cold hammer forged barrels. These rifles became the choice of elite military units around the world. In the United States, the Remington 700 platform gained enormous popularity. Its customizable design allowed militaries and police agencies to create highly accurate and affordable sniper systems. The U.S. Marine Corps formalized the M40 series, while the U.S. Army developed the M24 SWS. Optics technology also surged ahead. Variable magnification scopes, improved reticles, and repeatable turrets expanded practical engagement ranges. Ammunition quality improved with match-grade loads such as Federal Gold Medal Match and 7.62 NATO M118LR. Sniper rifles became more purpose-built, emphasizing ergonomics, modularity, and repeatable precision. This era created many of the features we still see on modern sniper rifles. The 1990s brought dramatic change. The combination of modern materials, laser rangefinders, and ballistic calculators allowed snipers to push past traditional distance limitations. The Accuracy International Arctic Warfare series became legendary. The AWM chambered in .338 Lapua Magnum extended effective sniper range to well beyond 1,000 meters. This cartridge would become the benchmark for long-range military precision. The United States continued upgrading the Remington 700 system with improved stocks, optics, and barrels. The Mk12 SPR emerged as a precision semi-automatic rifle for special operations, bridging the gap between sniper rifles and DMRs. Scopes became smarter. Mil-dot reticles became standard. Variable magnification improved. Turrets offered reliable tracking. Night vision and thermal clip-ons became increasingly available. The 1990s set the stage for modern long-range warfare by integrating precision optics, updated cartridges, and modular rifle chassis systems. The early 2000s introduced a new class of sniper rifle focused on anti-materiel rolls and extreme distance shots. The most iconic example is the Barrett M82/M107, a .50 BMG semi-automatic rifle capable of disabling vehicles, breaching barriers, and engaging long-distance targets. Though not as precise as bolt-action rifles, the Barrett brought unprecedented power to the battlefield. Meanwhile, rifles chambered in .338 Lapua Magnum, like the Accuracy International AWM and SACO TRG-42, became standard, long-range tools for military snipers. These rifles consistently achieved hits beyond 1,500 meters, with some record shots exceeding 2,000 meters. Cartridge development advanced rapidly. The .408 CHATAC and .416 Barrett cartridges pushed extreme range capability even further, though their adoption was specialized. Ballistic software evolved dramatically. Programs like Applied Ballistics and integrated handheld computers allowed snipers to predict complex firing solutions for temperature, humidity, wind drift, and bullet drop with far greater accuracy. This era redefined the sniper's role from long-range shooter to extreme-range precision technician. The 2010s introduced the modern concept of multi-caliber sniper rifles. Rather than fielding separate rifles for different missions, militaries adopted systems that could switch calibers by swapping barrels, bolts, and magazines. One of the most influential systems is the Barrett MRAD, selected by US SOCOM as the Mk-22 Advanced Sniper Rifle. It can switch between 7.62 NATO, .300 Norma Magnum, and .338 Norma Magnum without requiring an armorer. Other notable modular rifles include Desert Tech SRS Bullpup Multi-Caliber System, Accuracy International AX Series, CADX CDX Precision Rifles. Chassis systems became industry standards. Folding stocks, adjustable length of pull, modular mounting surfaces, and improved recoil absorption became expected features. Optics revolutionized again. Modern scopes include first focal plane reticles, precision zero-stop turrets, large elevation ranges, integrated cant indicators, enhanced coatings for low light clarity, thermal and night vision clip-ons integrated seamlessly into these systems, allowing 24-hour precision capability. Today's sniper rifles combine mechanical precision with digital technology. New optical systems integrate ballistic computers directly into the scope, calculating drop, wind, angle, and atmospheric conditions in real time. Digital optics, such as the tracking point system, introduced guided fire concepts, allowing shooters to tag a target and let the system release the shot at the optimal moment. While not widely adopted militarily, these technologies preview where precision shooting is heading. Modern cartridges such as .300 Norma Magnum and .338 Norma Magnum have become favored by special operations due to their long-range performance and manageable recoil. Rifles like the Mk-22 have set new standards for military use. Semi-automatic precision rifles have also improved significantly. Platforms like the HK417, SR25, LMT MWS, and SIG Spear now approach bolt-action performance while offering greater rate of fire and rapid engagement capability. Sniper training now integrates laser simulators, virtual reality, and complex range systems. Long-range shooting has reached distances once considered impossible, with confirmed military hits well beyond 3,000 meters. The sniper rifle continues to evolve into a fusion of precision engineering, digital computation, and ballistic innovation.